Hello, friends. Today, the topic under discussion is the microservices in ASP.NET Core. It's a very important topic in the interview point of view. So every company needs a resource who have a good knowledge about the microservices architecture in ASP with ASP.NET Core. If you watch this video completely, you can easily manage any microservices interview easily. So I have prepared 10 points of microservices architecture with lots of differences and lots of things. So please watch this video completely. So let's start with the video. The first question is like, what are the microservices? So microservices are, an architectural style that structures an application as a collection of small autonomous services modeled around a business domain. So each microservice is a separate unit that can be deployed and scaled independently. This approach contrasts with traditional monolith architectures where an application is built as a single invisible unit. Some I have prepared some key characteristics of microservices that include the single responsibility. Like each microservice is designed to handle a specific business function such as user authentication, payment processing, or any inventory management. In the communication perspective, microservices communicate with each other through well defined APIs, often using HTTP, REST. You can also use gRPC or any messaging queues for the communication, like RabbitMQ and all that thing. Microservices can be individually scaled, allowing for more efficient resource use. For example, if a particular service experience high demand, so it can be scaled without scaling the entire application. Different microservices can be developed using different programming languages and technologies. It allowing teams to choose the best tools for each task. The failure in one microservice do not necessarily affect the entire system because it uniquely and separately deployed, so improving overall reliability and robustness. See, okay, so we have also continuous deployment. So microservices enable continuous integration and deployment CI/CD practices, allowing for faster development cycles and more frequent releases. So we have different differences between the monolith architecture and the microservices architecture. When we comes to the definition, in the monolith architecture, the software development approach where all components are tightly coupled and packaged together into a single unit, sharing the same code base and runtime. These are the architectures that we were used like nowadays. So in the microservices, the software is broken down into a collection of small independent services, each running its own process. So when we talk about the coupling, so it's a tightly coupled monolith architecture, and the microservices is the loosely coupled architecture. And when we talk about the complexity, so monolith architecture, like it's easier to develop initially due to a single code base and environment. So when it comes to microservices, so it is more complex due to managing multiple services, each with its own code base and environment. So when we talk about the maintenance, so it can the monolith architecture can become complex and difficult to maintain as the application grows. So microservices is very much easier to maintain as individual services can be updated independently. The monolith architecture is like more challenging to scale as the entire application must be scaled together. Microservices is very easier to scale as individual services can be scaled independently. So monolith is very simpler to deployment, like as everything is packaged together. But in terms of the microservices, it is more complex. Deployment requires, orchestration of multiple services. So in terms of the cost, monolith is typically like less expensive to develop and maintain initially, and in terms of the microservices, so it can be more expensive to develop due to complexity and infrastructure requirements. So this is the differences. Like we have all, some more, like in the performance wise, monolith can have, better performance due to less inter-process communication, and the microservices potential, performance overhead due to network calls between services. So we have also differences in the flexibility, like less flexibility in the monolith and more flexible like the microservices. And we have also, in the monolith, it's a single point of failure. If one part fails, the entire application can fail. But in terms of the microservices, it's more resilient, like failure of one service doesn't necessarily affect the entire system. So we have different pros and, cons of monolith and microservices. So monolith is like simpler to develop and deploy initially, better performance due to less network, like it's a cost effective in the short term. When it comes to microservices, so it's more, flexible and easier to update, better scalability, higher, resilience due to isolated. So it is, for complex and large applications, the microservices is best. And when we comes to monolith, so it's best for the smaller applications. So when we talk about the example, so monolith example, like an e-commerce application where the user interface, business logic, and the data access are all part of a single code base and deployed as one unit. So when we talk about the microservices, or an e-commerce application where different services are responsible for user management, product catalog, order processing, and like payment. So each service is deployed independently and communicates via different APIs. So these are the different differences. And when we talk about, so the next one is the how do microservices communicate with each other. So we have different processes of communication between the microservices. The first is the RESTful APIs. So microservices exposes RESTful endpoints over, HTTPS for synchronous communication. So this approach is yeah, like simple and widely understood, making it suitable for client server interactions and CRUD operations. So the next approach is like messaging. So we have different messaging systems like RabbitMQ, Kafka. These, enable asynchronous communication. Microservices publish messages to queues or topics, so that, allowing other services to consume them at their own pace. So this, decoupled services and support scalability and fault tolerance. We have also a very important event driven architecture. So in which like events are used to trigger actions across microservices. So event driven systems use message brokers, or, event streaming platforms for event publication and subscription. So it, promoting loosely coupled architectures and real time responsiveness. We also have a remote procedure call, like RPC framework facilitates like synchronous communication between microservices. They define service interfaces, generate client server code, and, handle communication transparently. So it is very suitable for high performance internal interactions. So you should know all the communication methods in the microservices, but you can experience with one to two, but no, you have to make a knowledge like on all that. So we have also a service mesh. Like a service mesh manager is like service to service communication within a microservices architecture. It, provides features like service discovery, load balancing, security, and observability, like enhancing readability and network resilience. So We also have different database integrations in the microservices for communication. Like microservices can interact indirectly through shared databases, although it introduces coupling concerns. Like each service manages its database with interactions typically mediated through API calls to maintain loose coupling and ensure data consistency. So it is good approach to have like different databases with different services in the microservices. So we have different scenarios, like in which a social media platforms where user engages, like follow others and receive notifications. So I have taken the scenario here, like in the user services we have different so we have three services like here. So in the user service we exposes the RESTful API, like post users, you can get the specific user for the user management here. So it communicates via messaging to notify other services of user registration. Okay, so we have also a post service here, like that manages the user posts and interactions, and use RPC to fetch user profiles from the user service. So it you have to return the get user profile method here in that service. And we also have a notification service in which you that subscribes to event from the post service to send notifications on new post. Like you have to create a new post created event. So it exposes the RESTful APIs for managing notification settings, like I place the put notifications setting. So when we talk about the interaction flow, so when a user posts a message, the post service publishes a new post created event. Okay, so the notification service subscribes to this event and sends notification to followers of the user who made the post. And users can update their notification settings via RESTful APIs that provided by the notification service. So you can tell in the interview this type of scenarios, like you use these type of scenarios in the microservices. It will very helpful to boost your interview skills. Like, so we have also the benefits of that scenario, like decoupling. Like services operate independently, communicating through event and APIs, like reducing dependencies. So we have also scalability, like asynchronous messaging and RPC support, handling concurrent user interactions and notifications. Each service manages its data and operations, allowing for changes and updates without affecting other parts of the system. So this example showcases how microservices use RESTful APIs, messaging, and RPC to enable scalable, resilient communication in a social media application. So each communication mechanism plays a crucial role in maintaining system flexibility and responsiveness. Let's explain the concept of API gateway in microservices. It is very important because in the microservices there is a one API gateway as well. So in microservices architecture, each microservice handles specific business functions which can complicate client interactions with multiple services. So an API gateway solves this by providing a single entry point of clients to access all microservices. When we talk about the security, it enforces robust security policies such as authentication and authorization, safeguarding microservices from unauthorized access. So the API gateway efficiently scales to manage high volumes of incoming requests, which is like critical in complex microservices architectures. By caching responses from microservices, the API gateway optimizes like performance by reducing the latency and decreasing the load on backend services. So it also collects comprehensive metrics and logs, offering insights into the health and performance of the microservice architectures. It also facilitating proactive monitoring and troubleshooting. So we also have a logging and analytics in that, like it captures detailed logs and analytics about incoming requests and responses, like it providing valuable insights into usage patterns, performance bottlenecks, and API usage trends. So it, overall, the API gateway plays a crucial role in enhancing the reliability, scalability, and performance of microservices based applications, which, also ensuring robust security and effective monitoring capabilities. So we also very most important question is how microservice architecture works. So you have to tell the things in the steps, I prepared it in steps. First of all, the client, you have to talk about the client request. So clients, user from various devices send requests to the system, and then the API gateway forward that request to identify provider to authenticate user and issue security tokens. So the second step is the authentication, and the third step is the API gateway routing. The API gateway routes authenticated requests to the appropriate microservice based on the request type, and then we have a microservices service processing there in the picture. Like microservices process the request, interacting with their databases or external systems as needed, and then we have a service discovery and management that helps microservices to locate each other for communication. We have different management tools, monitor and balance microservices, like we have handling failures and ensuring optimal performances. And then we have a content delivery, static content is served to clients via storefront, a web app, and CDNs, so that enhancing performance by caching and delivering content efficiently. So we have also a response to client, we have processed responses from microservices are sent back through the API gateway to the client. So this is the whole how microservice architecture work. So we have also, how do you it's a very common question, like how do you ensure the data consistency in a microservice architecture. So you just tell that ensuring data consistency in a microservice architecture is crucial for the reliability and performance of the applications. So there are several techniques that can help maintain data consistency. So so these are different techniques, like eventual consistency. This model allows data to be temporarily inconsistent with the expectation that it will become consistent over time. It is suitable for scenarios where immediate consistency is not critical, or where achieving strong consistency would be too costly. So we have also a strong consistency there. Like this approach ensures that all read and write operations are immediately visible to all clients. So it can be implemented using distributed databases or distributed transaction managers, guaranteeing that data remains consistent across the system. So we have consistent hashing as well. Like this technique distributes data across a cluster of servers in a manner that ensures each server holds a consistent subset of a data. So it enhances performance and reliability, making it easier to maintain and consistent. So we have also a versioning. This is very important, like the versioning by tracking changes to data over time. So versioning helps to resolve conflicts between different versions of the same data. It also allows for easily rollback of changes if needed. So the choice of technique depends on the specific requirements of the application. So each of these method can contribute to improving the reliability and performance of the microservices based application. So we have a different, containers. I listed the role of containers in microservices as well. Like containers are a form of lightweight virtualization technique that allows an application and its dependencies to be packaged into a single manageable unit. So this greatly simplifies the deployment and management of applications within a microservices architecture. So it, additionally, containers, scalability is crucial for handling the complexity often associated with the microservices. So we have different benefits of the container, like when we talk about the portability. So containers can run on any environment that supports Docker. This means microservices can be seamlessly transferred between development, staging, and production environments. So containers are, easily scalable, allowing microservices to be adjusted up or down to meet demand efficiently. So this ensures optimal resource utilization and performance. So containers can be, quickly replaced if they fail, enhancing system reliability. So this means that any issues can be swiftly resolved without significant disruption to the overall application. So in terms of the security, containers provide isolation between microservices, improving security by preventing issues in one container from affecting others. So incorporating containers into a microservices architecture simplifies deployment and, management, enhancing scalability. So and also, increase reliability and bolsters security, making them invaluable of, for modern application development and deployment. So we have three C's in microservices. So I listed, like these are essential principles that are often associated with the microservices architecture. So these principles help guide the design and development of microservices based applications to ensure their effectiveness and success. So we have, componentization, in which, it emphasizes the breaking down a monolith application into a smaller autonomous services. Like these are the microservices. So each microservices handle a specific business capability, enabling independent development, testing, and deployment. So so we have a communication, the next C. Like it, for effective communication between microservices. So it is very crucial in a microservice architecture. So services interact via well-defined APIs, often using lightweight protocols that I told before, like HTTP, REST, or any message brokers like Kafka or RabbitMQ. So we have also a containerization, like it involves packaging application and their dependencies into standardized units such as Docker containers and other containers. So these are the containerization. These are the three C's. The another thing, like the interviewer asked, like what is the circuit breaking in microservices. So circuit breaking is basically a crucial design pattern in microservices architecture, like that aimed at, preventing cascading failures. So it operates by, isolating failing microservices and halting their communication with other microservices. So we have different monitoring and threshold in the circuit breaking. We have, opening the circuit. We have different recovery, each microservice maintains a failure counter. When a microservice encounters failures, this counter increments. If the failure count surpasses a predefined threshold, the circuit breaker activates. So when a circuit breaker triggers, it blocks further requests from reaching the failing microservice. Instead, it immediately responds with an error or a fallback mechanism. So circuit breaker remains in an open state for a specified time, allowing the failing microservices to recover. So once the service stabilizes, the circuit breaker resets the failure encounter and restores communication. So the implement when we talk about the implementation tools for the circuit breaker, like the first tool is the API gateway. These can enforce circuit breaking across all microservices exposed via APIs, centrally managing traffic and failures. So we have also a service mesh that I talked before, like the circuit breaking is very like important for microservices architecture. It is very indispensable for microservices architecture, as it mitigates the risk of widespread failures caused by one malfunctioning service. So by isolating failures and managing traffic intelligently, it enhances application reliability and ensures smoother operation during service disruption or high load scenarios. So the last question is the what is the role of DevOps in microservice development? DevOps and microservice are indeed complementary approaches that when combined enhance the agility, scalability, and reliability of software development and delivery. So we have the continuous integration practice, like CI remains pivotal in microservices development, by building, test, and different deployment processes. So this ensures that changes are integrated seamlessly into the application, maintaining its reliability and consistency across multiple services. So we have another thing, like the common deployment. So CD plays a crucial role in microservices services architecture by automating the deployment of code changes to production environments. So this rapid and reliable deployment process ensures the new feature and updates and delivered to users swiftly and without disruption. So you can use Azure, AWS, and other things for CI/CD. We have also infrastructure as code. So this continues to be essential in microservices environments, enabling teams to define and manage infrastructure through code. So this approach ensures that infrastructure configuration are consistently scalable and easy reproducible, like across various deployment environments. So we have also a monitoring and logging. There, like monitoring and alerting are like critical components of for maintaining the health and performance of microservices applications. So DevOps practices facilitate automated monitoring of metrics and system health. So enabling proactive identification of issues and timely alerts to ensure prompt resolution by development and operations teams. So that's the end of the microservices architecture. Thank you very much, guys. Please hit like and subscribe button for follow the more updates and more important videos on the topic. So thank